The sixth heuristic is recognition rather than recall. You want to make objects and actions, options to the user visible. People can see it and pick it. They don't generate it, right? Remember, our short-term memory is extremely volatile and small. We can remember 7 plus or minus 2 items, and that can be 30 seconds to maybe 2 minutes, depending on whether you're interrupted. So if you have to recall something when switching between interfaces, then that can be a real problem. Again, I think about two-factor authentication, right? Often you get a code that's about 6 digits, which means it fits within that short-term memory window, and you can go and type that into another interface. But increasingly, we're using techniques where you can just, press a button or autofill it in the two-factor authentication, and then you don't even need to have that short-term recollection, let alone a long-term recollection, which would be a lot more challenging. Things to support this might be menus rather than typing in commands. You do want to keep them short so that they're manageable, but still. Autofill, again, is good practice. It can help these as well. And prompts can provide format and limits to what people are trying to enter. Don't require retyping of remembered information. So when something's entered, you've got it, just reuse it. And use pervasive and generic rules. So cut and paste. Make sure people can do copy and paste whenever it makes sense. If you can't do it, then suddenly they're going to have to remember it, type it in. There could be more errors. It's just more challenging or more cognitively demanding. So an example of menus and prompts here. You have a list of the printer names. If you're doing this in the command line in a really old school way, you have to remember what the actual printer names are, right? You've got an example of what collating is. I can never remember whether collating is one order versus the other, and so it has that iconography to remind what that means. And it also shows what a handout is. So all of this different terminology, even if it's not, it is a bit specialized, and it allows you to communicate to the user what each of these terms mean, even if they might be familiar. It kind of reminds them or instructs them. Number 7 is flexibility and efficiency of use. You want to provide shortcuts for experienced users, so command keys. Allow people to jump directly to the desired location, reuse previously entered information, and good default values. They go a long way. If you populate everything with good default values, people don't have to change them, then that's really, really efficient. And this is a way to kind of there's ways to support both beginners and novices and experts. And having these kind of extra power features allow people who are using these interfaces repeatedly or have used similar interfaces repeatedly to go through them much more easily and quickly. Heuristic number 8 is aesthetic and minimalist design. You want good graphic design and color choice. You want to appropriately direct attention, like we've talked about, group-related objects using alignment, decorations, other Gestalt laws, and you want to balance with white space. You also want to maintain display inertia. You want to change as little as possible when updating the display. That's why you have common headers along the interface, and only when you get into like a very different environment do you change the headers or the side menus or etc. You want fewer fonts and colors, 5 to 7, to not be too distracted. You want to have appropriate contrast. This is especially important for accessibility, which we'll talk about soon. And some people are colorblind, about between 0.5 to 8% of the population, depending on different demographic information. And so you want to make sure you choose colors that are differentiable, even if you have some sort of color blindness. So you want to have variance in luminosity as well as hue. And again, we'll talk about this a little bit more when we talk about accessibility. Heuristic number 9 is helping users to recognize, diagnose, and recover from errors. You want to help users out when they're in trouble and provide opportunities for users to learn about the system. Remember, if they're experimenting with the system, they're building up the mental model, and it continues to get updated as they see the responses. Use clear languages. Don't use error codes, or if you have the error code, explain what it means. Error code might be useful for help at some point. And be very precise. Don't just say syntax error. I realize that in a compiler, there are certain problems that make it more difficult to give more detailed information. But the more information you can provide, the better, even just spitting out where you encounter that error. And you want to constructively help the user solve the problem so that they can resolve it and continue to finish their task. Tell why the error happened and how to fix it. You also want to be polite and not accusing, and use positive wording. So don't say fatal error. That's just like, oh, I just ruined my computer. It's going to explode now, right? You want to blame the system. You don't want to blame the user. You want to say, we didn't recognize that command rather than it's an illegal command. You should not have typed this. You want to avoid humor or snide comments. I mean, sometimes it's kind of funny in web browsers. When you get the 404 error, sometimes it's kind of endearing. But for the most part, you want to make sure you're clear. And humor can backfire in those situations. So make sure it's clear before adding that kind of extra bit of spice to your error message. You want to support easy error recovery, so people know how to fix things or can go and quickly undo. Direct people to where the unrecognized command was. Have multiple levels of messages. So if it says can't save the file, well, why not? And then see if you can give the extra bit of detail. So there might be different reasons that you can't save the file. Maybe there's no existing folder, or maybe there's already an existing file name and you didn't click overwrite, whatever. You want to be able to support that extra level of detail. So this is a set of violations right here. So it says internal error, could not process your request for registration, error 917. Now I know what error 917 is, so I'm perfectly happy to fix this out. But most users might not know how to do this. Just don't ask me what 9718 is. It takes too long to explain. Here, invalid tranche ID specified. Okay, I've got no idea. A good example might be, this relatively older web page for Yahoo Travel. Please correct the following errors. Arrival city or airport is required. Please check it. And it, even better would be to direct you to where it is. So now it's even better, right? It says, please enter location. It's in bright red, so that target is very recognizable compared to all the other targets. There's a high degree of difference, and it's co-located with the, where you're trying to go. So now, it's not only specified at the top, it's specified where you need to fix it, which helps. The final heuristic we'll talk about today is help and documentation. Most people will not read documentation. If they do, then it's either the first time the product is being used or they're in a panic, so they need information right away. So you need to iteratively design documentation, designed to be a reference for the case where you're, trying to troubleshoot something and you're desperately trying to get on your Zoom call and there's no, way to fix your computer. So you have to go and pull out the manual. And anyway, any documentation you have should go through iterative design. You should think about that carefully and do that user-centered design process there as well. Think about how best to support people when troubleshooting these errors. So those are the heuristics. Let's talk about conducting the evaluation. There are 3 stages. The first is briefing session. So those are the heuristics. Now that we've covered the heuristics, let's talk about how you conduct the evaluation. A heuristic evaluation has 3 stages. The first is a briefing session to tell experts what to do. The second is an evaluation period of 1 to 2 hours in which each expert works separately. They take one pass to get a feel for the product. They take a second pass to focus on specific features. And then they rate each issue found by all experts for severity. So they go through, find these things, and then say, this is very severe, this is minor, etc. You conclude with a debriefing session in which experts work together to prioritize problems. And because they've worked separately and then they come together, you have a wider set of problems caught and they can try to resolve recommendations in a more cohesive way. So in stage 1, briefing, if the systems walk up and use, like if you want it to be a kiosk at a mall or something, and or the evaluators are already domain experts, they already know how to use this interface, you don't need to provide assistance. You just kind of hand them the interface and let them go through it. Otherwise, you want to provide evaluators with scenarios, something that gives them an idea of what it is they're trying to accomplish, and then they go through and use the interface to do that. Stage 2 is the evaluation. You want at least 2 passes per evaluator, first to get a feel for flow and scope of the system, second to focus on specific elements. The evaluator will produce a list of problems. Usually there's an accompanying sheet that they will fill out, some sort of a template. And they want to explain why each problem exists with reference to the heuristic or other information. You want to be specific and list each problem separately, so you have all these atomic units that you can then go through and check later when you're trying to revise the design. Why do you want separate listings for each violation? You don't want to repeat every problematic aspect. Like if you keep repeating it, it may be difficult to keep track of everything, and it may not be possible to fix all problems. So you may want to track things moving forward in your design. Best way to do this is to look at an example. So here's an example heuristic. You have an ID. You have a heuristic. This is 4, consistency. You have a severity rating, which is 3. And you have a fixed rating, which is 0, probably the difficulty of how to fix it. The interface uses the string save on the first screen for saving the user's file, but by using the string write file on the second screen, users may be confused by this different terminology for the same function. So relatively severe, but pretty easy fix. You can change that string or make it more cohesive somehow. Severity is really important. It's used to allocate resources to fix problems and gives you an estimate of the need for more usability efforts. It's a combination of frequency, impact, persistence, is it one time or is it a repeating issue? And it should be calculated after all evaluations are in. So everyone comes through, they maybe take their own idea of the severity, and then you want to amalgamate everything to come up with a final conclusion of what that severity is. And it should be done independently by all judges, right? So everyone should voice their own severity, and then eventually you consolidate. You have different levels. 0 is I don't agree that this is a usability problem. 1 is a cosmetic problem. 2 is a minor usability problem. 3 is a major usability problem, important to fix. 4 is a usability catastrophe. It's imperative to fix. Stage 3 is your evaluation. You conduct with the evaluators, observers, and development team members. You discuss general characteristics of the user interface, suggest potential improvements to address the major usability problems, and the dev teams rate how hard things are to fix. That's where the fix rating comes from in this evaluation. You can make it into a brainstorming session. You can suspend judgment, build on each other's ideas. You notice that people work independently, then come together, follow all of the things that we discussed for ideation and generation of design ideas here as well to generate problems and then consolidate them into a final set of heuristics that were violated, issues, and potential fixes. So in summary, heuristic evaluation is an analytical evaluation method that asks 3 to 5 usability experts to evaluate the system. It uses a predefined set of heuristics that the experts will base their judgments on. For example, Nielsen's heuristics, H21 to H210, H2 being, I think, the version of the set of heuristics. It involves 3 stages: briefing together, evaluation independently, and 3, debriefing together. And you provide the severity rating in the evaluation phase. So make sure every expert's doing that independently. So you've got a choice between experts and users. When do you use discount methods? Let's compare heuristic evaluation to user testing. Heuristic evaluation is much faster. It's 1 to 2 hours for each evaluator plus, versus days or weeks to recruit people to come in for a usability test. It doesn't require interpreting a user's actions, right? You can have experts explain the reasoning why they want to fix everything. But user testing is far more accurate by definition. It takes into account actual users and tasks, whereas heuristic evaluation may miss problems and find false positives. A good idea is to alternate between heuristic evaluation and user testing. You find different problems, you don't waste your participants, so just keep in mind when you want to allocate your resources and when you should bring in experts for a quick evaluation rather than doing a full user study. So the key takeaways from this lecture are: discount usability methods use expert evaluation instead of user testing. It's cheaper and faster than user testing, but less accurate. And it's more flexible than predictive models. And heuristic evaluation is one such discount usability method. You get 3 to 5 experts evaluating the system using 10 heuristics, and it's a great example of how user-centered design can lead to benefits. So, be able to explain, justify, and conduct heuristic evaluations. This will form the basis of assignment 6, so there's no in-lecture activity today. Good luck, and I'll see you next time.